once again, it's time for another Calculus!
Kalye!
Calculations.
With us.
In lieu with our past episode, which is the application of derivatives,
Equation of the tangent line. Today's calculations will be all about
Drum rolls, please! Ta-da!
related rates!
Now you guys know that we don't settle for less, and we're once again taking math out into the streets because we've got another
Uy,
malapit. Yan.
Kalye calculations!
Ready for you.
I spotted one example.
Me too.
So did I.
We found 3 examples for you.
Here's example number 1. When the girl was standing in the street corner, there suddenly appeared a boy walking towards east at the rate of 23.1 centimeters per second. The girl's head was following this boy as he walks. Unknowingly, their position was forming a right triangle with these measurements. Well, as you can see, we are forming a right triangle here. Now the question is, how fast is the girl's head revolving? Well, we can solve this by the application of derivatives. We have the working equation of x squared plus y squared equals z squared, which is the Pythagorean theorem, since, again, our figure resembles that of a right triangle. So we get its derivative, which happens to be this, 2x times dx over dt plus 2y dy over dt is equal to 2z dz over dt. Now we have to substitute in this equation the values that we have to solve for the unknown, which is dz over dt, the rate of change in the hypotenuse with respect to time. Now we have already the values for x, the values for y, for dx over dt, which is negative 23.1 centimeters per second. Well, this is negative since x decreases with respect to time, so the rate must also be negative. Now for dy over dt, that is equal to 0 since with respect to time, y will always remain constant since there is no change in the length of y. So that will be equal to 0. Now we don't have the value for z, and dz over dt is unknown. So we use the Pythagorean theorem to solve for z. And here's the solution. 180 squared plus 118 squared is equal to z squared. And then extracting the roots, we have z is equal to 215.23. Now we already have the value of z, and we can now proceed into substituting it to the equation. So here's the solution. 2 times 180 times negative 23.1 centimeters per second plus 2 times 118 times 0, which will become 0, so that part is pretty negligible, which is, and it is equal to 2 times 215.25 z, which is the z a while ago, and times dz over dt. Now, here's what happens when we simplify it. Negative 8,316 is equal to 430.46 dz over dt. Now, to solve for dz over dt, we divide both sides by 430.46, giving us dz over dt is equal to negative 19.32 centimeters per second.
In example number 2, the girl saw the boy being slapped by another girl. As an initial reaction, she said wag, meaning don't in English, not knowing that she was already forming a circle. By that, it is now a related rates problem. Assuming that the radius of her mouth is 3.25 centimeters and the rate of change in the radius is 1.1 cm per second. Now, how do we calculate the rate of change in the area of her mouth as it opens? First, we should know our working equation, which is the formula of getting the area of the circle A being the area, is equal to pi r squared. The derivative of this equation is the derivative of A with respect to time is equal to 2 times pi times r times the rate of change in the radius. Then, let's substitute the given values to the equation. It would be the derivative of A with respect to time is equal to 2 times pi times 3.25 centimeters times 1.1 centimeters per second. Then, the final answer is 7.15 pi centimeters squared per second. That's all.
This last problem is somehow similar with the first, so we'll have this as a practice exercise you can work on. The complete solutions will be shown on the last part of the video for you to check on.